Good morning all. Now let us pass on to the next topic of the chapter, sound, that is about the characteristics of sound. So before we pass on to the characteristics of sound, we need to get acquainted with certain terms related to sound wave. That is, first one is about the wavelength. That is, when we learned about transverse and longitudinal waves, we learned about the waveform, and the peak point of the wave is called crest, and the valley point of the wave is called trough, and this peak point crest is similar to the high pressure region compression, and this trough corresponds to the low pressure region called rarefaction. So the sound wave has two parts: peak points called crest, which corresponds to the high pressure region called compression, and the valley points called trough, which corresponds to the low pressure region called rarefaction. And the distance between two consecutive crest or two consecutive trough, ഒന്നില്ലെങ്കിൽ രണ്ട് ക്രെസ്റ്റുകൾ തമ്മിലുള്ള ഡിസ്റ്റൻസ് or രണ്ട് ട്രഫുകൾ തമ്മിലുള്ള ഡിസ്റ്റൻസ്, this distance between the troughs or crest is called lambda, and it is denoted by the Greek letter lambda. Wavelength is denoted by the Greek letter lambda, and its SI unit is meters. So it is a distance between two consecutive crest or two consecutive troughs. അടുത്ത് കിടക്കുന്ന രണ്ട് ക്രെസ്റ്റുകൾ തമ്മിലുള്ള ഡിഫറൻസ് അല്ലെങ്കിൽ അടുത്ത് കിടക്കുന്ന രണ്ട് ട്രഫുകൾ തമ്മിലുള്ള ഡിസ്റ്റൻസ് ആണ് wavelength എന്ന് പറയുന്നത്, and it is denoted by the Greek letter lambda, and its SI unit is meters. Now the interval between two successive crests or two successive troughs, this time interval is a constant. The time interval between two crests or the time interval between two troughs is called the time period, denoted by the capital letter T, and its unit is seconds. Its SI unit is seconds. So the time interval between two successive crests, which corresponds to compression, or the time interval between two successive troughs, which corresponds to rarefactions, are constant and is termed as time period, denoted by the letter T, and its SI unit is seconds. Okay, so that is the second term, that is time period. Now the third term is about frequency. Okay, for that, all of us have heard the ticking sound of a clock, and we know that clock ticks once every second. ഓരോ സെക്കൻഡിലും ക്ലോക്കിന് ഓരോ ടിക്ക് സൗണ്ട് ഉണ്ടാവും. So the ticking of clock once every second is the frequency of the clock. That is, frequency of sound is the number of wave produced in 1 second. ഒരു സെക്കൻഡിൽ എത്ര waves, the number of waves in 1 second is called frequency. So the frequency of the ticking sound of a clock is 1 hertz, because in every 1 second clock ticks once. ഓരോ സെക്കൻഡിലും ഓരോ ടിക്ക് സൗണ്ട്. So the frequency of ticking sound of a clock is 1, and the unit of frequency is hertz. Unit of frequency is hertz, and frequency can be denoted using the Greek letter mu or using the letter small letter n or using small letter f. You can use either of the three representation to represent the term frequency, and its unit is hertz. So, frequency is number of waves produced in 1 second. Now, the wave started from here. Let us see how many waves are there in this picture given. So, wave is starting from the mean position. This is the mean position. So, from the mean position, the particle moved to the crest portion, again came back to mean, moved to trough, then moved back to mean. That is, if this is a simple pendulum, this is the mean position of the simple pendulum. When we oscillate the simple pendulum will come to extreme position. Then from this extreme position it will go back to mean. Again from mean it will move on to the next extreme position and then comes back to mean position. This constitutes one oscillation or one wave. So, one wave means one wave should constitute a crest and a trough. So, the wave starts from mean, crestiletti, tirichu mean, again to trough, back to mean. This is called one wave or one oscillation. This is one wave or one oscillation. This is one wave or one oscillations. Likewise, how many waves are there here? This is one. Again from mean, crest, back to mean, trough, to the next mean position. This is second wave. Now again starts from mean, crest, mean, trough, mean. So here ends the third wave. Similarly, mean, crest, mean, back to trough, again back to mean, fourth wave. Mean, crest, back to mean, trough and mean, fifth wave. So here we have, so a wave consists of a crest and a trough. Tirichu mean position one wave or one oscillation. Here time interval given is 1 second, and in 1 second there are 5 waves. There are 5 waves in 1 second. Therefore, frequency of this wave is 5 hertz. Number of waves in 1 second is the frequency, and it is represented by the letter nu, and here frequency is 5 hertz. So, it is the number of waves in 1 second. So, the 3 important terms related to a sound wave are, first one is wavelength. Wavelength is represented using the letter lambda and its SI unit is meters, and it is a distance between two crests or two troughs. Second term is time period, denoted by the letter T, and its unit is seconds. That is the time interval between two crests or time interval between two troughs are a constant, and it is called time period. Third term is frequency. It is represented using the letter nu, n or f, and its SI unit is hertz. It is the number of waves in 1 second. Oru secondil etra waves, that is called frequency. So, to find frequency, just find the number of waves that is passing in 1 second. Okay. Now, the fourth term is the amplitude. Amplitude means when a particle vibrates. When a particle vibrates, the maximum distance, the maximum displacement covered by a particle is called its amplitude. Suppose if a simple pendulum is oscillating, This is the mean position. Now, we make the simple pendulum oscillating. The maximum distance covered by the simple pendulum from the mean position. The distance covered by the pendulum from the mean position is called amplitude. Mean positionil ninnum pendulum etra distance, maximum distance vare poi. That is called amplitude. So, this is the mean position of the particle of a sound wave. This is the mean position. So, the particle vibrated in an upward manner to so much distance. So, this displacement of particle from the mean position, this is the mean position. This is the mean position. So, the distance covered, displaced by the particle from the mean position is called the amplitude, or we can simply call the amplitude as height of the wave. The height of the wave is called the amplitude. This height of the wave is called the amplitude. It is a maximum distance or maximum displacement that have undergone by the particle is called amplitude, or simply we can say that it is a height of the wave and is denoted by the letter A, and its SI unit is also meters. The SI unit of amplitude is also meters. So, these are the 4 terms related to a sound wave. Hope the 4 terms are clear for everyone. Now, let us pass on to the characteristics of a sound wave. For that, consider screaming of a girl and cooing of a pigeon. What is the difference between these two sounds? Yes, the technical explanation is related to the concept called pitch. It's related to the concept called pitch. And pitch is the interpretation of frequency of a sound by the brain. It is the interpretation of frequency. Okay? And screaming of a girl is a high pitch sound, means its frequency is high. So, pitch is related to frequency. If frequency is high, it is a high pitch sound, and if frequency is low, it is a low pitch sound. So, pitch is directly related to frequency. If frequency of a sound is high, such a sound is called high pitch. So, for high pitch sound, frequency is high, and for a low pitch sound, frequency is less. Now, consider this case. Suppose if this is 1 second. Just find the frequency of both the waves. See, wave started from here, crest, mean, trough, back to mean position. So, it is 1 wave. Now, mean is start crest, back to mean, trough point illa. That means here we have 1.5 wave in 1 second. That means frequency is 1.5 hertz. Now, see this case. Started from mean. This is first wave, second wave, third wave, fourth, fifth, 6 waves. So, here we have 6 waves in 1 second. That is, frequency is 6 hertz. So, here the frequency is 1.5 hertz and here the frequency is 6 hertz. That is, frequency is more for this wave, hence such a sound is called high pitch sound. Here frequency is only 1.5. So, frequency is less and such a sound is called low pitch sound. Cooing of a pigeon is a low pitch sound, while screaming of a girl is a high pitch sound. Now, we know that the distance between two crests is called the wavelength. So this is the wavelength of high pitch voice and this is the wavelength of low pitch voice. So here in low pitch voice, wavelength is more, while in high pitch voice, wavelength is less, that is shorter wavelength. If wavelength is shorter, frequency will be high and such sound is called high pitch. And if wavelength is longer wavelength will have low frequency so the sound will be a low pitch sound. So if wavelength is short, frequency will be more and sound will be high pitch. If wavelength is long, frequency will be less and the sound will be low pitch. So these are the points to be remembered under the topic pitch. So pitch is related to frequency. If frequency is more, it is high pitch, and if frequency is less, it is low pitch. If the wavelength is having a shorter wavelength, if the wave is having a shorter wavelength, then it is a high pitch voice, and if wavelength is more, it is a low pitch voice. These are the points to be remembered while you study the first characteristic of the sound, that is pitch. Now let us move on to the second characteristic, that is quality or timbre. For that, consider two of your friends are talking behind a wall, okay, but you will be able to recognize them by just hearing their voice, even if you don't see them. How? It is because of their uniqueness of the sound. Every person has a unique sound, and this characteristic of a sound is called quality or timbre. That is the uniqueness of sound. Uniqueness of sound is called quality or timbre. That is, it helps, this characteristic of a sound helps to differentiate sound from another sound with same pitch or loudness. Even if the sound have same pitch or loudness, we will be able to identify different sounds because of the characteristic called quality or timbre. This is the second characteristic of the sound. Now, when you switch on a computer, sometimes you hear a beep sound because of some error, okay, and such beep sound are uniform sound with one single frequency, okay. So the beep sound heard from a computer because of some error has a single frequency, or such sound are uniform which have a single frequency, and the sound with single frequency is called a tone. The sounds with single frequency is called a tone. Now consider the sound heard from a music player. The music heard from a music player. It is a blend of several frequency. The music heard is a blend of several frequency. Or acha music il pala frequency undavum. And such a sound is called note. If it is a blend of several frequency, if a sound has several frequency, such a sound is called note. If a sound only has a single frequency, such a sound is called a tone. And if note is pleasant, such a sound is called music. And if note is unpleasant to our ear, it is called a noise. So a pleasant note is called music and an unpleasant note is called noise. Okay. Now listen to my sound. Can you hear me? Can you hear me? What is the difference between these two sounds? Yes, one sound was louder. and the other one was soft. Now let us see what makes these sounds different. It is the characteristic called amplitude. It is a characteristic called amplitude. That is, the loudness of a sound depends on amplitude. If amplitude of a wave is high, if amplitude means height of the wave, if amplitude of the wave is high, such a sound is louder. If amplitude is less, if height of the wave is less, such a voice is a softer sound. It's a quiet sound. So loudness depends upon amplitude. If amplitude is more, sound will be more louder. If amplitude is less, sound will be feeble. And the unit of loudness, the SI unit of loudness is decibels. Loudness is measured in the unit decibels. Loudness is measured in the unit decibels, and the relation between loudness and the amplitude is, loudness is directly proportional to amplitude square. As amplitude increases, loudness also increases. It is in direct proportion. This is the relation that connects loudness and amplitude. There is a relation that connects loudness and amplitude. As amplitude increases, loudness also increases. Okay. That is the third characteristic of a sound. So the three characteristics are, first one is pitch. Pitch depends upon frequency. If frequency is high, wavelength will be short, and such voice are called high pitch. If frequency is less, wavelength will be more, such voice are called low pitch. Now second characteristic of the sound is quality or timbre. It is the uniqueness of a sound. And the sound which have a single frequency is called tone, and sound which have several frequencies called a note. Now the third characteristic of a sound is loudness. Loudness depends upon amplitude, and the SI unit of loudness is decibels. Now as amplitude increases, loudness also increases. If amplitude is more, sound will be louder, and if amplitude is less, sound will be feeble. So these are the three characteristics of a sound: pitch, quality or timbre, and third one is loudness. So the three characteristics are clear. Thank you.